Welcome back. In this video, we're going to continue off of the distance class we created in the previous two video lectures, and this time we're going to focus on making it a little more safe. So last time we finished up with this overloading of the plus operator. So now let's take a look at something that we didn't really like since the very beginning, this public distance constructor. Now the problem with this is, we're depending on the user to feed in the input as meters. But what if the user would rather, work with miles? It feels quite natural to work with miles. There's miles right here. So why should we force the user to convert to meters for our distance class if they're only ever going to use it for miles? That doesn't seem, very good. So what we're going to do instead is we're going to make this private. Now this might be interesting if you've never seen a private constructor before, but they're usually used for stuff like this, data hiding. So if we take a look here, notice we're still inside of the public class distance, so we can call our private constructor from our public constructor. That's no problem at all. And remember, this static operator, this is also inside of our distance class. So just as we could get the private member variable, we can also get the private constructor. So what we're going to do is provide another way for users to create a distance from miles, perhaps. So let's just start with the base case, meters. Nice and simple. So we're going to do public. And remember, this is going to be static because this is not bound to an instance. We'll have a distance, and we'll say from meters. So we're going to create a distance from meters. And then we will say decimal, because that's our underlying type, meters. And then we'll return a new distance from the meters. And it's as simple as that. So you'll notice, back in our original program, we can't do this anymore because we don't trust the user to remember this is, this is meters. Because look, if I just open this up as a user, it doesn't show anymore, but it wouldn't show, it would show the fact that the parameter is called meters, but we don't want to depend on the user doing that. So what we're going to do instead, we're going to say distance, and look, Visual Studio is already ahead of us. But we're using distance because we want to qualify a static method, dot from meters, and then we feed it the meters that way. So see, this works just like this, except it protects the user from this ambiguous constructor. And this is useful because, what if we really do decide that miles are more useful for us and it'd be better to have miles as the default? Well, the client code doesn't change at all because they've been constructing from meters this entire time. While here, if we change this 6, if this goes from working on meters to working on miles, that changes all of the client code, and that's not very good. So we'll see if we do distance.from meters and we give it a 6. Just like that, we run it again, we get an 11. As we'd expect. 5 plus 6 is 11. Now, we can also do this for miles. From miles. Now, notice we're going to have to do a little bit of conversion here. Oops. So I already brought this up ahead of time. 1609.34 Remember, we use M because that's a decimal literal. Excuse me, miles. And we can use this as well. Now, we shouldn't be in love with this either because look, we have a concept of miles to meters here, and we have a concept of miles to meters here. So maybe it would be better to say something like we have a private const. And this is another thing that's different than Java and C#. In Java, you would have to do a private static final. Const variables are always static by default in C#. You don't need to qualify them with static. In fact, I don't think the compiler even lets you. See? If we try to do this, it'll say, you can't mark it static. And that's because this is static by default. And the reason that it's static is, remember, this const is independent of instance. If it were not independent of instance, then every instance of distance we created would have its own copy of a constant. And that's sort of wasteful. There isn't really there's not a great reason to do that. Why store a constant, 50,000 times if you're making 50,000 copies? So what might be better for us in our situation is to say something like meters to miles. And then we use, let's see, actually, let's make this even more explicit. Meters in a mile. And there are this many meters in 1 mile. And that way, we can do meters in a mile instead. And instead of doing this, we could do something like maybe 1 over meters in a mile. So, this is a little cleaner because we have all of our numeric calculations in one place. And you shouldn't be afraid of this. You shouldn't be afraid of doing this because really, the compiler's smart and it'll optimize this away. So this division isn't going to be happening every single time you run this. This will do this, at compile time. So, don't worry about efficiency there. Actually, you know what? I'm kind of doing this on a whim. So double check to make sure that this math works. I'm like 99% certain it does, but it's not like I, double checked. I'm a little under the weather, unfortunately, but that's my excuse anyway. So the idea is basically something like this is preferable. So we have our nice from miles, we have our nice from meters, we have our protected constructor, we are using our very precise decimal, we are using private consts. So this is now a pretty, this is the beginning of a pretty robust distance class. So while we're still here, I'd like to go over a couple of other things. So here you see, we have an as meters, and you might ask, why didn't we implement this as an auto property? Why didn't we give this a get and return meters like this? And the answer for that is, the answer for this is we could do it this way, but the reason we don't want to do it this way is, one, whenever you have an auto property, there's usually an agreement between the person who makes the class and the person who consumes the class that all it's doing is returning a value, or maybe, it's flipping a Boolean condition. It shouldn't be doing, much in the way of complex calculation. Now, it's up to you to say if this is a complex calculation, if that conversion is a complex calculation. If you feel that, your application isn't that pressed, then by all means you can implement it that way. But know that if you put it in a Windows form or WPF control like a list box or something, it shows all the public properties, which means every time you update it, it'll update all of those values and have to run all those conversions again. So that's something to be mindful of going forward. So I think this is another nice logical takeaway from this. I'm going to undo this and keep this as a function. And yeah, that we just made our distance class a whole lot safer.